Hey everyone, my name's Karl Weinmeister, and I'm with Google's Developer Advocacy team. And I'm going to talk to you today about using TensorFlow on Google Cloud Platform. So you may be familiar with TensorFlow and machine learning. Maybe you've used Google Cloud Platform or not. We're going to see how these technologies come together in this session. Our agenda today will include starting with TensorFlow Enterprise, and then we'll talk about the various ways that you can use TensorFlow on Google Cloud, starting with virtual machines, training, serving, explanations, and cloud TPUs. We'll also show a little bit of demoing as we go to see these technologies hands-on. We'll see code samples, we'll see how to use the product. So what you're going to see today is focused on the AI platform. There's a wide spectrum of different levels that you can work with machine learning on Google Cloud. We're going to be talking about the AI platform, which provides tools. It's not AutoML, nor is it at the lowest levels of working directly with infrastructure like GPUs, but it's a set of tools to enable you to build models with TensorFlow. The big picture with Cloud AI Platform is that it provides an end-to-end set of services for building machine learning models, starting with ingesting data, analysis, transformation, training, and so on and so forth, to eventually giving you a model that you host in the cloud and use in your production applications. Briefly, to introduce TensorFlow, it's an open source deep learning library that was released by Google in 2015. We're now on version 2 of TensorFlow, actually now version 2.3 at the time of this video. And it's fantastic library to use. And it's much more than a library, really. It's a ecosystem. And you see below all the different ways that you can use TensorFlow in IoT applications. There's a JavaScript version for running in the browser. And there's all different ways that you can use TensorFlow. It's got a huge community, and you can see some of the links for tensorflow.org. I highly recommend the tutorials, by the way. Perhaps you get interested and want to take a look afterwards. There's a great range from Hello World type of work to very deep material that will help you in your machine learning journey. Let's start with TensorFlow Enterprise. So what is TensorFlow Enterprise? It's Google's build of TensorFlow that focuses on 3 different capabilities. One is cloud scale performance, which essentially means that we've created performance optimizations in the build of TensorFlow so that you can be assured that it runs quickly and takes advantage of the hardware on Google Cloud. The second piece is managed services, where you can use TensorFlow for training in the cloud, serving in the cloud, notebooks, et cetera, without worrying about deployment and installation and managing servers and that type of thing. So we have a wide variety of different ways you can use TensorFlow on Google Cloud. Finally, enterprise-grade support, where some of our users are always looking at the latest version of TensorFlow. Some of our users, though, might want to anchor on a certain version of TensorFlow that's going to last for a while. So what we're doing is we're backporting key fixes to make sure that users can stay on a same version of TensorFlow for a while. So just to dive in a little bit more to some of these points, from a performance perspective, we see that there's integrations with cloud storage and BigQuery Reader. When you're pulling in massive amounts of data, the I/O is a key aspect of performance. And so without any code changes, you're able to take advantage of our optimizations for these input sources. I'm not going to go too much into managed services because that's really the heart of this presentation today. With enterprise grade support, as I mentioned, if you happen to use an enterprise version of TensorFlow, there's a 3-year long-term support roadmap for that. All right, so let's dive into deep learning VMs and notebooks. So you might ask, why are these 2 topics combined together? Notebooks, our development environment for deep learning, are based on top of the same deep learning virtual machine images. So they're very connected products, and we'll talk about that now. So some of the pain points for machine learning is that installing frameworks is hard. I'm sure that we've had trouble with installing different packages, different drivers for using GPUs with drivers, et cetera, and getting those all kind of working nicely together. The other aspect is reproducibility, where you might have different team members using different versions of packages, and having everything being reproducible is key to get the same results from your models and build the models in the same way every time. So one solution to some of those problems is deep learning VM images. So these are virtual machine images that contain a tested set of packages and pre-installed libraries that work well together. So all you need to do is deploy that virtual machine image, and you're good to go with a machine learning environment for TensorFlow, but as well as other frameworks, scikit-learn and others that we have on the platform. Now let's start to look at how do you create an instance. So we're going to show a couple code samples as we go. Here's from the command line. We're looking at creating a TensorFlow VM instance. You see here we're using the gcloud command, and then we create the instance. We need to tell it which zone. We point to a particular image, and you notice it says TF2 enterprise latest GPU. So there's different variants: TensorFlow 1, TensorFlow 2, a CPU image, and GPU image, et cetera. And all of these images are located in a common project, this deep learning platform release. So that's what it takes to deploy one of these standard images. And let's now talk about notebooks, okay? So AI platform notebooks are a secure enterprise grade Jupyter Lab solution. If you haven't used Jupyter before, it's sort of one of the most popular development environments for data science. And so we have an ability to quickly deploy a Jupyter environment with just a click or two. Okay, so each of the notebooks run on top of that DLVM infrastructure, and they have Jupyter Lab running in that image via reverse proxy. So you're able to directly access Jupyter Lab and then train and do all the different things that you need to do within that same VM image. As we see here, you can easily create a new instance of your notebook environment. And with a couple clicks here, we are selecting, with GPUs or not. You can customize your instance and get into a lot of details around, what size of storage or how many CPUs, et cetera. That's all available to you. And then you have your notebook environment. There is an SDK for notebooks as well. So you can run the gcloud beta notebooks command to create an instance. It's, again, very similar to the compute command, but this is a little more specific to create a notebook. So let's briefly take a look at this code with a demo. So what I've done here is I want to show you a couple code snippets of using this, the DLVMs and notebooks, right? So we are actually in the AI platform notebook environment. As you can see, I have my list of images or instances, and all I did was click Open Jupyter Lab to get here. So I'm here in my notebook, and what I'm going to do is kind of walk through each of these cells in the notebook to just show how it works. So you can see that I've got my own project parameters. We're going to kind of skip through some of that. We're just going to show how to create a new instance. So the first command you see here is that same ability to create an instance. I've actually already created one, so the command will tell me that it's already created. But I'm next going to show you a different command, which shows you, like, let's say, the list of instances. And we'll see that I do have my instance here, my DLVM. It tells me the port that it's running. So just this is a neat way if you want to see the different types of commands for gcloud compute, the different things you can do here. So that is Google Compute Engine, where you run our DLVMs. Now let's take a brief look at notebooks. Okay, so for each of these different services, we can use an SDK, where here we're going to use Python code to run some of these commands. We can also use the command line, which I showed in the presentation. So here, let's try using the Python SDK. So we would first install the package. I've already done that, so that'll be fast. We'll import a couple library or modules here. We'll instantiate a client. Here, we're going to list the instances running of our notebooks, okay? So let's take a look. We're gonna get a response coming back. And let's just see the name of the first instance. Okay, here we go. So within my project, we've got a TensorFlow 2 notebook server running. Okay, that was via the Python SDK. Let's also do the same with the command line. So I'm going to run the notebooks instances list command. And here we go. We're going to see that same list of instances that you may have seen in the user interface here, right? And we see that the first one coming back is that same TensorFlow 2 image. And you see, what machine type, et cetera. So here we've seen how to use both the compute engine and the notebook SDKs and CLIs on Google Cloud to set up a TensorFlow notebook instance. Okay. All right, so let's move forward. Let's talk about training a model. Okay, so the AI platform provides a training service that allows you to train models without worrying about infrastructure. So if you have a large model, you can run it on the distributed cloud infrastructure. You can take advantage of specialized hardware. There's hyperparameter tuning so that you can find the optimal parameters for your model as well. And now let's walk through the steps to train a TensorFlow model. And there's several different ways to do it. I'm going to show you a user journey using Docker. Okay, so this may be new to you. This may be something you're very comfortable with, but just keep that in mind that we're going to show using containers as one way to go through the training process. Let's just dive in. Okay. First, you're going to create your model and training code. So what you're seeing here is a convention of splitting the model code and then the code which trains the model. You don't have to do this, but you see that in some of our samples. Okay, so this is just, we're not going to focus too much on the model itself, but you see that this is a model that has several layers, and on the right side, you see we're using Keras here to fit the model that performs the training. And that would be an example of the code that you would need to write, and you're going to deploy that code onto the cloud to do your training. Okay, and you can find examples of this under Google Cloud Platform in GitHub in the Cloud ML Samples repo for various sample projects. Okay, so once you've written your machine learning code, you would create a Dockerfile. So what we're doing here is we are basing it off of a base image. Remember that same TensorFlow 2 latest GPU image, we're extending it. And then what we're doing is we're copying those files into the image. And then the final step here is pointing out when we start the image, the entry point is that task.py file. So if you used Python before, you might be familiar with, there's a main function where if your code is going to run there. So you have some main function defined, and that's where the training code would get kicked off. So that's what it takes to create your Dockerfile. The Dockerfile defines your starting point. And then from there, and I'm not doing this here, but what you could do is you could install additional Python packages, for instance, or just copy your training code like I've done here. And that's it for your Dockerfile. Okay, so now let's say we have our Dockerfile. We've got a link to like an image location where we want to push our Dockerfile. And then what we're going to first do is build the image. So we point to the Dockerfile and then where we're going to deploy the image. Next, we might test the image locally. And I recommend this because it saves some steps. Maybe the way that you've configured your image has some issues. The training code isn't quite working correctly. So you can run it locally. And as you see here, you can pass parameters into that image. So maybe what you might do is run through fewer passes of the data, just like here we're doing epochs. Maybe set it to 1. Just does it work end to end? Don't do your full training, of course. Then the next step is pushing to the container registry. And then you've built the image, and now you're pushing the binary up to the cloud so that you or other members of your team can use it in a training scenario. Okay, so now you have your image. How do you submit your training job? So here's the command for that. G-Cloud AI platform, and then you have you're submitting your training job. There's a couple things that you're going to pass in here. The region, the location of your image, and then you see everything after this / These are custom parameters. So these are not required. This might be things that your particular image accepts as parameters. Maybe learning rate, epochs, batch size. If there are things that you want end users to be able to pass into your image to customize your training process, you can pass those in as well. So everything above here is standard to AI platform, and then your training code parameters would be below. So another great capability is hyperparameter tuning that's part of this process. So if you include a configuration file, you can say, I'd like to find the optimal learning rate or other parameters here. I'm going to provide a range like you see below here, the min value and a max value. And it's going to search across combinations of these different hyperparameters to find the optimal values that result in the lowest error for your model. Okay, so you would define a config YAML file for that. Then in your training code, you just need to make sure that that you have an ability to pass in arguments. Again, this comes back to like epochs that you saw in a previous slide, or here a learning rate. You're going to parse various arguments coming in if specified, and this allows the hyperparameter tuning to pass different values in as it tries combinations. To take advantage of this, in your training job submission, you would add the -- config parameter to enable this. Okay, so you're able to see the job in the console. At the top, you're seeing a list of the different jobs, and if you click on one of the jobs, you'd see below more details. So you could click on the logs, and you could see, was it a successful training job? It's all accessible in the UI as well as the command line. So let's take another look at this in the demo. Okay, so I am going to walk through a real world model. The first thing I'm going to do is create a training directory where I'm going to store all my different files. And here's an example of a task py file that I mentioned. So what I'm doing is I'm just parsing these different arguments as I described. I have a simple model. So in this case, I'm not actually going to put the model in a separate file, just keeping it a little bit simple. I have, I'm doing the MNIST image classification example. It's very famous. So I just have a simple model for that. Here in my main method, I'm parsing arguments coming in. I'm loading data for MNIST. I'm training my model, and then I'm exporting my model. So after I'm finished creating the model, I'm going to put it in a storage bucket so that I or other users can leverage the asset that was created. That's it. And so in this file, what I'm going to do now is I'm going to simply create the file, task.py, and write it out. Okay. So what I might do first is just test this training code locally before deploying it. Just run through task.py, just make sure that everything is okay. Again, I'm just going to do one epoch. We don't want to spend forever doing our training. But what you might do in the cloud is run lots of epochs or work with a larger data set. Okay, so great. So that completed. Now let's walk through the steps for a custom container. So as we described previously, we're going to create a Docker file. So here I'm going to print out a Docker file. You can see here if I go to the train directory, that's it. I've simply got one file, my task.py. And I'm, again, in this case, basing it off of the CPU image. The next step, I would build my container image off of that Docker file. This may take a little while. I've already built it, so that's not too bad. Now let's try another test. I'm going to test my container locally. And then I can actually queue up some of these different commands. So I'm gonna, you see a star, it's running right now. So let's go through all this stuff, and I'll just kind of keep going. I'll push my image as well. And this should just take a sec. And it'll prepare the image, and we're good to go. All right, so let's show the final step of this process, right? We've created a Docker file, and now we want to submit the job. So what I'm going to do here is I am simply going to submit my training. You know, I do have a few of these different parameters. In short, I'm specifying the name of the job, the region, the location of that Docker or container, and then some of the custom information like 10 epochs and where do I want to produce the model when I'm finished, the job directory. And so we would just go ahead and submit the job. And it comes back telling us that it's queued. And so for the purpose of this talk, we're not actually going to wait the 7 or so minutes that I've seen that this takes. But what I am going to do is just kind of show you how it's done. And then if you want to check status, of course, you can go to the user interface, but also there's a describe command so that you can see, okay, great, now we've moved on to the preparing side, preparing stage. And it tells you where to get the logs and so on and so forth. So now you've seen training in the cloud. We've built a model, we've created a Docker file, and then we've taken advantage of the training service. Okay. So let's move on to serving a model. So you've created a model. That doesn't do any good unless you're, sharing it with others if it's being used in applications. So let's talk about prediction. So Google Cloud has an offering called AI Platform Prediction. And AI Platform Prediction is based on Google Kubernetes engine for scalability under the hood. And it provides you an endpoint where you can take the model that you've built and wrap it with the REST API. And it has configuration options for auto scaling. So as you get more workload, it will scale out. And when it's getting less workload, it will scale back down to 0. So, or whatever you decide as far as minimum amount of scaling. So it's got a lot of configuration to serve models exactly as you'd like. It logs all the prediction requests to BigQuery, and you've got a lot of different choices as far as infrastructure on this service. Okay, so let's walk through the steps to use the AI Platform Prediction service. So first, we need to deploy our model. So if we think about what we did in the last section, we exported our model to a location in, let's say, a Google Cloud Storage bucket, the job directory. We put it in an export folder. The first thing we would do is create the model on AI Platform. This step is really more about creating the package, almost the metadata. It's not actually deploying the binaries yet. So we're creating a model in a region, but it's not quite real yet until the next step. The next step is where we create a version of the model. So we tag it with a version and we point it to the model binaries. And the, say, version of TensorFlow that we'd like to use. If we want to update the configuration, like let's say we want to change some scaling parameters, what we might do is create another version of the model. So we kind of, that's the way that we sort of update the serving configurations. So how do we make predictions? Let's walk through another example. So let's say just we have a couple data points that we're going to pass in. These are the features of our model that we're using to predict a new value with, and we put it in sample.json. There's two different ways that we can do prediction. One is an online prediction, which is, I need an answer now. And what that does is simply you pass in the name of the model, the version that you want to use, and then the test data that you want to predict with. That's all you need to do. The other way of using it is for batch prediction. So a use case for this might be where you've just got a lot of data that you want to run predictions on. It's not necessarily time sensitive, maybe it's part of a nightly batch job or something like that. You pass in a couple of parameters, the input paths of where your files to be predicted with are, and then where the prediction results are going to go. And then finally, you specify the data format for those input files. And there's a variety of different formats that are accepted for that. TF record, JSON, et cetera. Okay, so we've now shown different ways to predict. Let's show using the SDK, right? So there's a REST API that we show at the top. If you happen to use Karl or something like that, here's the format of the URL with the version, the name of the product, and the predict operation. Let's say we're using Python. There's an SDK for that. You might pass in the location of your model and then the instances that you want to predict on, and then you get a response back. Here's another example in Java, right, where there's a little bit of code to kind of create that request object to pass in to the library. And then here's an example of getting a response back. So a couple examples, Python and Java. All right. So we've seen how to predict with the model. Let's talk about some new capability that takes prediction to the next level, not just getting an answer, but providing insight into why that answer was given. So there's now explanations on AI platform, and it's not just for tabular data, text, and image models deployed to the Cloud AI platform through that prediction API. And it basically, there's a couple different workflows here. You start with building your image, you deploy to AI platform, and then you can simply just use that AI platform prediction API that we just discussed. Also, if you happen to use the what if tool, which is a great tool for more data analysis on why different data points ended up the way they came out of the model, you can use that as well. So that's got some integration into explanations, but we're going to focus on this left path. There are several different supported explanation methods, and here are some links to research papers that describe those approaches in more detail. And when you run explanations, you can specify which technique you would like to use. Very similar command to get explanations. We create a new version, and then we tell it a little bit more information using, I like to use an explanation method when I create a version of my model when I'm serving it. Okay, so once we've deployed our model, we can call the explain operation on it to get this kind of information. So we see some JSON coming back, and maybe that's not the most intuitive right out of the gate, but let's take a look in more detail and try to explain what's happening with the explanations. Okay, so in this example, it happens to be looking at a model that is about rental bikes, kind of like a rental car type of service, but for bikes that's actually in the BigQuery public data set. Okay, what we're trying to predict is the average duration of the ride in minutes, okay? And so in this particular case, we start with a baseline. So let's start from the top and work our way down. You have a baseline prediction, and that could be anything. In this case, it's going to be the median value in the data set. So the typical prediction is going to be 13 minutes, okay? In this case, with the data that we passed in, our predicted duration is 10.7. Why? So what we're doing here is when we're printing this out, we're parsing that JSON data and we're sorting it by the absolute value to kind of see what made the most impact first. Okay, so the first thing we see here is distance. So, and I'm not sure exactly if that's, meters or what the exact units were here, but for that particular value passed in, it pushed the value down from the median. So apparently the distance of the bike ride was, less than typical, right? So it subtracted a couple minutes. The next thing was the start hour. So that looks like the second most important feature in the model, telling us that also reduced the time by another minute. Maybe it's a time of day where it's not so busy, where the rental bikes are, there's plenty of them available, or traffic isn't really an issue, et cetera. So then you kind of start to get into some other things. Well, maybe the temperature is an issue, and that actually brings up the value by 0.69. So it, as a whole, what this does is it allows you to see for your prediction what features kind of shifted the value to arrive at the prediction that you got. Okay. The last thing I want to talk to you about today is cloud TPUs. So cloud TPUs are available on Google Cloud, and they allow you to train and run large ML models at high speed and scale. Okay. So let's look at how to take advantage of these specialized chips on Google Cloud. The first step, prerequisites, maybe not the most exciting thing, but worth knowing, is that you'll need to enable some APIs. All of the Google Cloud services you can use from the UI, but if you need to use them programmatically via a CLI or an SDK, you'll need to check the box or press the button to enable the API. That's also via the command line you can do that. The second thing you need to do is enable Cloud TPU access to the storage bucket, right? So where you're reading in files, for instance, to train your model. So here's what we might do is kind of, if we remember about creating a notebook server. So we're going to run the command to create a notebook server. And in this case, we're going to use the same name, TPU demo. We're also going to create a TPU node that will be associated with that notebook server. So we create a TPU node, we can specify an accelerator type and a version of TensorFlow. I highly recommend, if you're working with TPUs, using at least 2.3, which again is the latest one at the time of this video, has a lot of improvements to the usability of using TPUs with TensorFlow. Now let's see, how do we use the TPU in our training code? And I think you'll see after a little bit of initialization, there's not much difference in using TPUs. So the first thing that we're doing here is we're pointing to the address of the TPU. So when I create a TPU in the Google Cloud Console, it's available here in the compute engine under TPUs. And so I can see this particular TPU and its internal IP address. Okay. And so in my code, I can point to that, and then I'm going to basically get a pointer to that TPU here. And there's some code here to resolve access to that TPU. The next thing I'm doing here is I'm creating a strategy. And you might be familiar with in TensorFlow, there are different strategies for running distributed training, a mirror strategy, et cetera. There is a TPU strategy. And so you pass in that resolver object, okay? And that's pretty much it. You have your strategy. What you need to do is within the scope of that strategy, you compile your model. Now, remember, compiling your model isn't training your model. It's simply defining the architecture of that model. And then once you've done that, you don't have to be in the scope of that strategy anymore. You've pretty much completed that TPU specific code. And so now once you're done with that step, you can fit, evaluate, predict, et cetera, and you'll be able to take advantage of the TPU. Okay, so I just wanted to point out, in case you want to use TensorFlow with TPUs, it's become easier than ever before, and you can take advantage of these great chips. Okay, so that kind of wraps up the presentation for today. We've kind of taken a tour from understanding TensorFlow Enterprise to the different ways in training, predicting, to some of the more advanced new capabilities with TPUs. Let's look at a couple quick resources. These are all code labs at codelabs.developers.google.com, where you can learn more and hands-on try out TensorFlow and Google Cloud. And that wraps up our session for today. Thank you very much.